Now we are going to calculate the ripple factor as well as the efficiency. This is your ripple factor and efficiency when we have inserted a capacitance of 100 microfarad. The load resistance that was of 1 kilo ohm, and we have connected a capacitance of 100 microfarad. This will improve our DC component. Now initially that we have calculated from the lab, it is 80.707 and the ripple factor is 0.54. Now with the introduction of capacitor, this will improve. Means ripple factor is going to decrease, ripple is going to decrease, and efficiency is going to improve. Now with this value, we are again going to find out the VAC component, VDC and VRMS of the VAC, VDC of the output. Now what will be how our output will be looking? Now here, when it will be starting to discharge, now it is going to take some time and it is going to be like that. This is the output that we are going to get this manner. This is going to come close to our DC. Now in literature, if you see, this ripple is given by formula 1 by 4 root 3 into R into F and into C. This is the frequency at which we are operating. Whenever C came into effect, we need to note down this frequency, and the R that we have connected 1 kilo ohm and C is 100 microfarad, and frequency we are operating at 10 Hz. Now at that we are going to jot down VAC, VDC and VRMS, and then we are going to calculate ripple factor and efficiency. Now we are going to zoom on the circuit. If you look at the circuit, in addition to this R, I have connected this capacitance, and if you look at the output will be looking like this one. This is your output. Now if you want to calculate all this value, this is mean value is around 5.52, means DC component has increased, and this is your RMS value, the mean value. Now if you want to calculate the BAC component, to calculate the AC component, press channel 1, make to AC coupling, and you see this is your AC. Now let me move the level below so that we can measure that AC component. This RMS is going to give me the AC. It is around 558. This is your 558 AC component that we got. Now if I calculate that VRMS we have seen. Now if you want to see once more, now do the DC coupling. This is your DC coupling. Move the level trigger so that graph will become stable. Now press measure. Now if you see, it is around 5.52 and it is 5.60. Now jotting, it is 5.52 and 5.60. This is the value that we got. Now if you want to see, without, this is the where it is operating, it is around 9 Hz, 10 Hz. Now I am removing the capacitance, and if you want to see, this is the output. Now if you want to see more, this is the output that we were getting. Initially we were getting around this one 4.20. Now let me make to first DC. This is your DC coupling. It is in DC coupling. Now go to measure. This is your output. Now whenever I will insert this one capacitor, if you see, your output is going to change. Now this is your output that we were getting. Now this is your output. Now if you want to enlarge that output, this is how we enlarge. Now this was the output that we were getting. Now for exact calculation, we make this one so that it is around 5.48 and it is 5.56. And for the measurement of AC component, press channel 1, go to AC coupling, and this will give you AC coupling. Now we are going to see the result and see the changes in the ripple factor and the efficiency. Now if you see that calculated AC value is 0.558, that 550 around millivolt we have calculated, and VDC is 5.52 and VRMS is 5.60. Now if I calculate the ripple factor VAC 0.558, 5.52, it is around 0. And from the literature, with this variation RFC, we have calculated around 0.14. It is almost matching. Now efficiency, if you see the efficiency, VDC square by VAC square, VRMS square, VDC we have 5.52 and RMS is 5.60. If you do, it is around 97%. Now if you see with capacitor, this has increased to 97% and ripple factor has been come down to 0.1. So this is all with the help of capacitor. Now if you want to see one more thing, see our DC component, it was 5.434, now it has increased to 5.52. Now with the introduction of capacitor, there is always an increment in the BTC. So this is all about your full wave rectifier with the capacitor.